Hello everyone, welcome to the solution of LeetCode problem 525 named Contiguous Array. In this problem, we are given a binary array nums and we have to return the maximum length of a contiguous subarray which has the equal number of zeros and ones. Suppose in the first example, the array contains two elements which is 0 and 1. So the entire array is contiguous. That's why we have to return 2. In the second example, the array is 0, 1, 0. So here, the first portion 0, 1 or the second portion 1, 0 has the equal number of zeros and 1. So here, the output is 2. Now the constraint are, the array length can be in between 1 to 10 to the power 5 and each of the array element is either 0 or 1. I hope you understood the problem statement. Now let's move on to the algorithm. Now, to solve this problem, let us try to figure out a pattern. Here, we can simply solve this problem by using the counter of 0 and 1. Suppose, we take a variable, suppose count. It will count the net number of 0 and 1. Suppose initially the count value is 0 and we have to iterate each of the elements from left to right. Suppose we are at this first position 1. So now the count value is 1. Now we are at this second position which has the value of 1. So the count value will be 2. Now in this third position, the value is 0. So we have to decrease the count value by 1. So here the count value will be 1 again. Now here the position holds the value 0. So we have to decrease the count value by 1 again. So here the count value will be 0. Now for these positions, it has 1. So we have to increase the count value. So it will be 1. Now for this last position, it has another 1. So here we have to increase the count. Now the count will be 2. And we can place this 6 value here. So it will be, count will be 1, 2, 1, 0, 1, 2. Now, let's try to figure out some of the pattern. Here, we can clearly see that, suppose, in this portion, the first value of count is 1, the last value of count is 1. So here, the count value is 1. And the count value is same. So here, as in this portion, the count value is same. So we can say that this is a balanced subarray, which has equal number of 1 and zeros. Now again, this portion has the equal number of count value, which is 1 and 1. So we can conclude that this portion is the balanced subarray. Similarly, this portion has equal number of counts in his left side and in his right side. So we can say that this entire portion can contain one another balanced subarray. Again, this portion has the same count value or same count value in the left side and in the right side. So we can say that this portion can be another balanced subarray. So here, can you see a pattern? Here we have found 4 subarray which are balanced and their length will be 2, 2, 4 and 4. So here among all of them, the maximum will be 4. So here the maximum length of subarray which is balanced is 4. Now, did you actually figure out the pattern? The algorithm is very simple. We have to calculate the net count value for each of the element, and we have to check whether the corresponding count already appeared before or not. If the corresponding count already appeared before, that means in those kind of cases, we have to subtract the index number of those positions and upgrade our corresponding answer. And to store the corresponding count and corresponding index number, we have to use the map data structure. So I hope you understood the problem statement. Anyways, let's visualize an example by using one of the maps. Now, at first, let us erase this. Now, we have to take one map. So suppose this is our map and this is our answer value. Initially, the answer is 0. Now, we are at these positions. Here, the net summation of the net count of the corresponding element is 1. So we have to check whether 1 is presented in the map or not. Currently, 1 is not presented here. So we have to add 1 into the map and corresponding index number, which is 0. And by default, we have to store the value position of 0 will be -1. Now, for these positions, the net value is 2. So we have to check whether the value 2 is presented in the map or not. Here, the value 2 is not presented in the map. So we have to store the value 2 with the corresponding index number 1. Now, for this element, as we have found 0, so we have to decrease 1 of the count variable. So here the count will be 1 or the net value will be 1. So here we have to check whether the value 1 already presented in the map or not. Yes, here we can see that the value 1 is already presented in the map. So we have to subtract the corresponding current index, which is 2, minus the corresponding entry of the value 1, which is 0. So here the value will be 2. Now the answer will be 2 because 2 is greater than 0. Or alternatively, we can say that this portion can be formed a balanced subarray. Now, for this fourth element, we have found 0. So here the net will be 0. So if we found 0 into the corresponding map, we can simply ignore it. Now, suppose we are at this fifth positions. Here the net value will be 1. So we have to check whether the value of 1 is presented in the map or not. Yes, the value of 1 is presented in the map, and the first index of this value 1 will be 0. So here the balanced subarray length will be 4 minus 0, which will be 4. That means alternatively, we can say that this portion of the array can form a balanced subarray. So here 4 is definitely greater than 2. So we have to upgrade the answer with 4. Now we are at this last element, which has the value 2 as the net value. So here we have to check whether the 2 is presented in the map or not. Yes, 2 is presented in the map. So we have to calculate the subarray length, which is 5 minus 1. this 5 in there is the index number, and this 1 is the corresponding value in the map. Now it will be 4. So the answer will be 4 again. Or alternatively, we can say that this portion of the subarray can contain a balanced subarray which has the equal number of 0 and 1, and the length of this balanced subarray is 4. So here the final output for this problem is 4. I hope you understood the pattern and visualize the algorithmic work procedure by using this map data structure. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named firstMaxLen, which has an input vector as a parameter. Now we are using one map and initializing some of the variable, and we are currently initializing the maximum variable with 0, and n stored the size of the current input array, and current sum will be 0, or we can say that this sum will be the net value of 0 and 1. Now initially, map of 0 will contain the value -1. Now we have to iterate each of the element from left to right, and we have to upgrade our sum. If our current element is 1, in this kind of cases, we have to add 1 with the sum. And if our current value is 0, then we have to subtract 1 from the sum. Now we have to check whether the value sum is currently presented in the map or not. If it is presented, that means we can form one balanced subarray here. So we have to upgrade the answer. So the maximum value will be the maximum of max and I minus the corresponding entry of the sum into the map. Otherwise, if we did not find any of the corresponding sum into the map till now, that means we cannot form any balanced subarray. In those kind of cases, we have to simply store the current index position with the corresponding sum. Finally, we have to return the answer. I hope you understood the code. Now let's move on to the time and space complexity analysis of this program. In this program, the time complexity is big O of n because we have to iterate each of the element from left to right, and the space complexity is also big O of n because we are taking one extra memory to store the corresponding index number, and in the worst case, the size of the map can be equal to the size of the input array. That's why the space complexity is big O of n. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.